Okay, so today we're going to do temperature and volume. And shout out to B4. I found this online. So look at the chungus. Look at him. He's huge. He's a mega chungus. So Charles's law tells us that temperature and volume have a direct relationship. And your goal is to be able to use that relationship to either find the final temperature or volume when the pressure and moles are constant, or to just say if one increases or decreases. So temperature of a gas is directly related to volume. When pressure and moles are constant, that means is that if we increase temperature, then volume increases as well, because you're heating those particles up and they get more kinetic energy, so they spread out. It's direct, so your graph looks like the chungus. So from now on, when something has a direct relationship, you can think of the megachungus. It's bigger together. Here's your formula. V1 over T1 equals V2 over T2. All your temperatures have to be in Kelvin for this formula to work. So remember that if you have Celsius, you add 273 to get Kelvin. If you have Kelvin and you want to go back because the book is being silly and asks you for an answer in Celsius, then Kelvin minus 273. Which I guess that does make sense because we tend to think in Celsius, I think more oftentimes than not. So if you needed to rearrange it for, in this case, we're looking for V2, then if the one that you're trying to get rid of is on the bottom, then you can just multiply by that number. So T2 over T2, which is the same as multiplying by 1, cancels these out, and then you get V2 on a side by itself. You could do the same thing with T1, just multiply by T1 here and cancel it. The conceptual questions are pretty easy. Just think about hot air balloons or tires when it gets cold, how they shrink. When you get up to drive to school and your tires look flat in the wintertime, that's because the particles inside have cooled down. Once you drive and it heats up a little bit, they'll go back out. Temperature decreases if volume decreases. When temperature decreases, volume decreases. Here you're going from 12 liters to 4 liters. So the temperature is going to decrease because the volume is decreasing. Here your temperature is increasing from 15 to 45, so that means your volume increases as well. Don't have to change that to Kelvin to see that relationship, but if you wanted to put it into a formula, you would. And there's word answers. I like pictures better. Computer stuff. If we're solving for T2, since it's on the bottom, you can cross multiply, if you remember, because two fractions are equal to each other. So now I would have V1 times T2 equals V2 times T1. Just cross multiplied. And if I want T2 by itself, now I'm going to divide by V1. So T2 is equal to V2 T1 over V1. Here it is typed out, the same thing. So if you're solving for the variable that's on the bottom, you're going to cross multiply and then divide. Example problem. A balloon has a volume of 785 milliliters at 21 degrees Celsius. Always mark that. If the temperature drops to 0, what is the new volume? So both of these are in Celsius, which means we're going to have to add 273 before you even start. Always do that first so you don't forget. And here it is filled out in a table. These are already put into Kelvin. So 0 degrees Celsius is 273 Kelvin. And now we are looking for V2. If we solve the equation for V2, we get V2 is equal to V1 times T2 over T1. So we just multiply both sides by T2 to cancel them on this side. And now you're just going to put your numbers in. It's okay to have milliliters, that's not a problem. Just make sure that you have your temperature in Kelvin. Plug it in, volume, temperature, temperature. This is our unknown volume, 729 milliliters. Just multiply 785 times 273, then divided by 294. So that's the end of this one. I hope that helps. One more time, chungus. Bye.